Hello, everyone. Welcome. Thanks for joining our diagnostic training session today. Now, what you're about to see is a pre-recorded training session we did over in the United States. But be assured that a lot of the material that we cover is really applicable to any automotive application. So just be aware that yes, it is a lot of North American vehicles, but a lot of the same principles apply over in the UK as well. Now, if you have any questions, if you're watching this during the premiere, you can just leave it in the chat. We'll be monitoring that. And if you're watching this after the premiere, then just feel free to leave a comment underneath the video, and we'll get to those as we can as well. So my name is Jason Gabrenas. I'm one of Snap-on Diagnostics technical trainers. I've been in the training department since 2013, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple years as a diagnostic sales rep at Snap-on, so I had a group of about 30 different franchisees I worked with, as well as the shops that they service, in order to help everyone get the most out of their diagnostic needs. Then before I did that, it was 8 years at Subaru, so I worked in a dealership, and over time, I guess, I just became that default diag guy in the shop. So I always ended up having the drivability problems, the intermittent problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird head scratcher type cars that had come into my bay. Then before that, a bunch of other miscellaneous wrenching jobs. Been a little over 25 years under hood experience for me. So our topic today is going to be modern braking systems design and diagnosis. We're going to walk through some of the more modern, I guess. I mean, it's come a long way in the last decade or so, right? With automatic emergency braking and traction control, things like that. So we're going to walk through different components and kind of how it's designed and laid out, and a couple different ways to diagnose it, maintenance, that sort of thing. So first off, let's talk about anti-lock braking systems, which is going to be, I don't think they sell cars nowadays that don't have anti-lock brakes. So usually they're going to use 3 to 4 wheel speed sensors. I think pretty much any vehicle nowadays is pretty much going to be on the 4 wheel speed sensor train. It's going to have an electronic control unit, of course. It's going to have a hydraulic pump and solenoids in order to pump the brakes. And it is designed to pump those brakes faster than a human possibly could in order to control wheel speed. And it'll do it individually as well. So if one wheel locks up, it'll pump the brakes on just that one, right? And it reacts in milliseconds, if not faster, right? And modern systems can apply and release 15 times a second. So that's pretty gosh darn fast. And if you've ever run into that type of situation where you had to, hit the brakes really hard and hit that ABS, you can feel it. It gives you a pretty big vibration in the pedal there. Different system types you'll see out there. One sensor, one channel. That's on the older trucks with rear wheel only ABS. You're probably never going to see that on a modern vehicle. 4 sensor, 2 channel, operated front and rear separately. That's kind of an older channel as well. 3 sensor, 3 channel, 2 independent front wheels and rear wheels together. 4 sensor, 3 channel, front wheels are independent, rear wheels together. And now, of course, most vehicles in the modern era are going to have 4 sensors and 4 channels, right? So all 4 wheels can be pumped and operated separate of each other. Different types of speed sensors you're going to find. We really have a passive or an active. And a passive is your classic, electromagnet, basically. You have a metallic rotor that's going to be on the drive shaft or the axle shaft, and then it produces a signal. And then an active one is going to use an encoder wheel on there, which is a bunch of permanent magnets in a rotor, usually in the inner bearing race. And then you're going to have 2 different sensors, magnetoresistive sensors, that go into a little chip, which decides a few things. How fast is it going, which direction it's going, can also tell that. And then it sends that signal off to the computer. I remember when my mother had an old, I think it was like a 2001 Explorer. And later on in its life, when she would come down to a stop sign, doesn't matter what the conditions were, dry, wet, hot, cold, didn't matter. Whenever it got down below, say, like 5 miles an hour or so, the ABS would fire. And it took them a long time to figure it out. Now, I wasn't, kind of around back then doing this sort of thing, so I really didn't know. But back then, so they ended up figuring out, I got lost in my story there. She ended up figuring out that there was rust on the metallic rotor in a spot. So when it would hit that, it would think that it would just not see it, and I guess it supposed that the wheel was slipping, and it would fire the ABS. So replace the ring. It was really just the axle shaft, right? Replace that, and all good to go. Right? I saw that a couple times at Subaru too, in the CV shafts. They had the metallic rotors on there as well. Same thing would happen. So let's talk about magnetoresistive sensors, since that's going to be our more modern style sensor that we're going to use. Like I said, it's got a magnetic rotor in the inner bearing race. It's a permanent magnet. It's a encoder wheel, we call it. And then it has the two sensors that kind of merge. So in order to do that, or what that does for us, is that it's going to read those magnets, and depending on which it sees first, either the South Pole or the North Pole, it is going to know, okay, I am going forward. And in this case, I don't know who makes this sensor off the top of my head, but in this case, sensor A reads it first, so it sends out a square wave and it knows the vehicle is going forward. In this case, sensor B reads it first, so it knows it's going backwards, and it also outputs a modified square wave. So you have a spike and then a dip and then a spike, and then a spike and then a dip and a spike. Right. So that's how the computer would know whether or not the vehicle is traveling forward or backwards, which is good to know because some modern vehicles nowadays have automatic emergency forward braking and also automatic emergency reverse braking. Right now, of course, it would know whether it's in drive or reverse, but still it knows which way the wheel is going, and that can help apply and do what it needs to do. So here's just another kind of description of that. This is off a Nissan. Power supply is supplied to the detection portion, so the magnetic field line is red. Magnetic field that is detected is converted to a current signal. When the sensor rotates, the magnetic field changes. Magnetic field change is converted to current signals in a rectangular wave and is transmitted to the ABS actuator and electric unit or control unit. Change in magnetic field is proportional to wheel speed. So you'll see the faster it goes, it will change. All right, so here's an example on GMC Acadia. Right, so wheel speed sensor is a 12-volt digital sensor. Electronic brake control module sends a 12-volt reference voltage signal to each wheel speed sensor. As the wheel spins, the wheel speed sensor produces a square wave DC signal voltage. The wheel speed sensor increases the signal frequency as the wheel speed increases, but does not increase the amplitude. Now, on older, non-magnetoresistive ones, they might increase in amplitude and the frequency would get closer together, right? So in this case, the faster it goes, the closer the waves get, but they don't get taller. Right? And it gives you, and this is how a guided component test, of course, so it gives you the wire colors and when you pin out and everything. That's for the left front, right front, etc. And then if we were to scroll down and take a look at that, it look kind of like this, right? Just a simple square wave. As it speeds up, it gets closer together. As it slows down, it gets further apart. All right, some tech notes. On some vehicles, the following codes or symptom codes may be set: C0035, 0040, 0045, or 0050. ABS light may be illuminated. This may be caused by bits of ferrous magnetic debris stuck to the wheel speed sensor magnetic encoder ring. Remember how we talked about that the encoder ring is a permanent magnet and it's inside the hub. Most vehicles have this now. So if there is some ferrous material, some steel, iron, what have you, from things wearing out, rust, whatever it happens to be, in that area, it will stick to it because it's a magnet. So these vehicles use a speed sensor encoder ring with north-south magnetic pole pieces encased in a nitrile rubber ring, typically brown in color. It's part of the wheel bearing. If experiencing any of these symptoms, this ring may be cleaned using a soft nylon bristle brush or equivalent. If any debris remains, mild soap detergent may be used. Wipe dry after the procedure. Use care to prevent damage to the wheel bearing seal. Important not to use any kind of magnetic tool to remove the debris or the encoder may be damaged. So first thought someone might think is, oh, it's a bunch of magnetic material, so I'll just use my little magnetic pickup tool to do that, and that can cause issues with the magnetization of the encoder wheel. So do not do that. Use a soft nylon brush. And here is GM's wonderful artist rendition of what that might look like. I don't know how they even came up with that. You'd figure they'd be able to get a picture of it somewhere. But anyways, that's kind of how it looks when it's covered in debris, and just kind of wipe it off nicely, keep it clean. Here's another example on a Volkswagen Passat. So that is this is an issue where I believe it's the speed sensor can be installed incorrectly, either swap sides or something like that, and then it goes in too close to the bearing, and you can see how this is all wore off in there. This is where the encoder wheel would be, right? So like a nitrile rubber cover, the cover's gone, and then you can see how the plastic is worn there as well. So that can cause a problem right there. Hello. There we go. All right. Here's an example on a Dodge Charger. So this was spinning by hand, right? So raise the wheel in the air. As the wheel spins, the sensor will produce a square wave that varies by about 400 millivolts, cycling between 10.4 and 10.8 volts. So the meter is going to be set to focus on this pattern. Yes, it's going to be, 4/10 of a volt. That's not a lot to see. Like if you had it on like a 20-volt scale, you're not going to see the difference there. But however, if we take our cursors, we go, we have negative 2.17 to 0.2, that's 0.417. So that's roughly 400 millivolts cycling top to bottom. So that's just another way that you might see that there. And that's kind of an interesting one, I think. So that leads us into traction control, vehicle dynamics. Other manufacturers have, their own, trademarked names for it or whatever. So use the ABS as well as additional sensors. So like a yaw rate sensor or a multi-axis acceleration sensor, including a steering angle sensor, possibly a steering effort sensor. It's going to modulate the braking to gain traction on slick surface. So if I'm like kind of sliding, drifting, or if I'm in snow or sand, it's going to modulate the braking in that case, while slick surfaces and then the skidding after that, right? So here's an example on that Acadia again. So depending on the options, the following vehicle performance enhancement systems are provided. So ABS, traction control, stability control, dynamic rear proportioning, hill descent control, hill hold start assist, corner braking control, hydraulic brake assist, optimized hydraulic braking system, intelligent brake assist, trailer brake control system, and trailer sway control. Right? So those are all the different options that they may use that would use this type of system. So it's not just for brakes and it's not just for traction control. It can be for a lot of different things. And then the following components listed below are involved in the operation of the brake system. So the electronic brake control module, brake pressure modulator. It's going to be containing the brake pressure sensor, hydraulic pump with pump motor, 4 isolation valves, 4 dump valves, 2 traction and stability control supply valves, 2 traction and stability control isolation valves, a high pressure accumulator, and a low pressure accumulator, right? So we've got a lot of different components, and this is just inside the hydraulic unit itself. And then a bunch of other things, body control module, brake pressure sensor, instrument cluster, multi-axis acceleration sensor, multi-function switch, steering wheel angle sensor, transmission control modules, because it's going to receive high-speed serial data message inputs from the transmission control module indicating gear position of the transmission for hill start assist or hill hold, and active wheel speed sensors, right? So a lot of different components feed into these systems, right? So yaw rate sensor. So yaw, if you don't know what yaw means, that is the side-to-side motion of something. So in this case, the vehicle. So as it's moving side to side on its kind of its center axis. And as such, the yaw rate sensor is generally going to be installed somewhere along the center line of the car. Yaw rate and G sensor. This is on a Subaru Forester. Detects changes in vehicle direction, detects the motion by moving electrodes built into the sensor. The sensor will send ABS control unit a signal by changing voltage. You see it's just a CAN communication. In that case, located in the center console next to the parking brake. And then in order to test it, you're going to check the output with a scan tool with the yaw rate and G sensor installed. The value should read yaw rate of -4 to 4 degrees per second. And the G sensor should be -1.5 to 1.5 meters per second squared. Unbolt the yaw rate or G sensor at an angle 90 degrees forward, rearward to the left and to the right. It should read 6.8 to 12.8 meters per second squared. And that would be just a data pin. Here's an example on that Acadia again. So yaw rate and lateral acceleration sensors are combined into one multi-axis acceleration sensor module. So it's just in one module, external to the electronic brake control module. The electronic brake control module receives serial data inputs from the yaw rate, longitudinal, and lateral acceleration sensor. So there's 3 different sensors inside this box. If power and ground of the sensor are okay, check signal circuits for high resistance, open or short to ground or power. A DTC may be set indicating the type of fault. So it just simply communicates over CAN bus and sends signals. So in order to test it, we can do a DC voltage test, really. So just check for 12 volts. You can also check the CAN waveform for that as well. All right, steering angle sensor, right? So it's going to tell the car where the steering wheel is in circular 360-degree space. And then on some vehicles, on the other end of the steering shaft, could be a torque effort sensor. So this one, I believe, is on the Denali as well. So that's at the end of the steering shaft where it goes into the rack. And that'll tell us how much torque is being applied to the wheel, whether you're turning it hard or slowly. or slowly or quickly, basically, because all of these things come into play when it makes its calculation as to, oh, which brakes do I need to apply and how much do I need to apply on them. Then we have the hydraulic unit. All right, so you have some solenoids in here, and your little reservoirs there. That kind of goes together in one piece, like these slot into here, right? Here it is, kind of just kind of sitting off to the side, right? So we can see the different solenoids there and the different accumulators and whatnot. Right. Now let's talk automatic emergency braking. So many modern vehicles, especially those equipped with ADAS, are going to have what's called the automatic emergency braking, which either uses a combination of the camera or the radar in the front of the vehicle and or the radar on the front of the vehicle to calculate how quickly you are approaching a vehicle and whether or not you need help stopping before you get there. Because maybe you have the pedal applied not quite enough, according to what it thinks is going to happen coming up ahead, right? Obviously, keep your wits about you and know what's going on the road. But yeah, it can outbrake you if necessary, if it needs to. And sometimes I will tell you, I don't remember if I have a slide on this, but I will tell you that I know on my vehicle, it can be awfully sensitive in reverse. I'll tell you that. I got, rearward cameras and all that other stuff, and it still may think there's an object there that's moving towards me, or there's just an object there in general, and it's not there. So it can get kind of interesting. It just applies the brake, slams it, and you gotta do some stuff. So in this case, it's under ADAS Control Unit 2. Distance sensor measures the distance from the vehicle ahead and transmits the distance sensor signal to ADAS Control Unit 2. Front camera unit measures the distance from a pedestrian and transmits the pedestrian ahead signal. Judges the possibility of a collision from a sensor distance signal, the pedestrian ahead signal, and the vehicle speed. ADAS Control Unit 2 performs the following operations according to the degree of possibility of a collision. First off is the buzzer output signal, the combination meter, and sounds the buzzer. Then it transmits a meter display signal, the combination meter, and displays the state of the system on the information display. Transmits the brake fluid pressure control signal, the ABS actuator, and electronic unit, and it performs the brake control. And then it transmits the stop lamp request signal to the BCM and turns on the stop lamp. So it does all this stuff for you. So it'll do it when these following conditions are satisfied. So vehicle speed approximately 5 kilometers an hour or more. And for pedestrian collision, approximately 10 to 60 kilometers an hour. The possibility of collision with a vehicle or pedestrian ahead. So that's automatic emergency braking. Your mileage may vary depending on the vehicle, but always refer to repair information, as I say. All right, let's go to maintenance, right? So part and parcel of this is also going to be the electronic parking brakes that we seem to have on just about every vehicle nowadays. Now, there are a couple different types of electronic parking brakes. There are some that retract the caliper entirely and move it in. Actually, let's go back even further, right? So many of the early electronic parking brakes were a rear drum type system, right? So I remember on Subaru when they first came out with this, you used to have the handle, and that would push the brake drums into the center drum, and then you had a disc on the outside for disc brakes. Then when they went to electronic parking brake, they just took the handle away, gave you a switch, and then it was an actuator that would basically pull the cables that the handbrake was pulling, right? So it would just pull the cables in. And then it went to calipers, right? So just about, most manufacturers, I believe it's in calipers at this point. But there are a lot of little things that you need to pay attention to. There's a lot of little gotchas that can come along the way too, that we've learned along the way. And actually, I'll show you a couple screens where we give you some advice to help you along the way. So in this case, here's an electronic parking brake. You can see that it's got the motor module on the back, and then there's the piston there. So in this case, this one does screw the piston in and out. So we can see how it's got a motor, and it's got some worm gears here, and then it turns the screw in and out in order to put that. And this is just for the parking brake, right? The piston is normally hydraulically operated just for the regular braking, but in this case, it has a screw that pushes it in and out to apply the parking brake. All right. Sometimes it will simply pull the actuator back, and then you have to push in the piston manually, like just a regular hydraulic braking system. Normally, you would operate, right? And then, like I said, there may be some gotchas out there. So 2025 and older, and probably newer, Kia Telluride also applies to Hyundai Palisade. please keep the doors closed on the vehicle when you're doing parking, when you're doing the maintenance. If the parking brake applies once you open the door should stay open the whole time during service mode, because the act of opening the door activates the parking brake even if it's in service mode. So if I put that car in service mode and I'm sitting in the driver's seat and then I open the door, it will apply the parking brake, and then you have to open them again. But we did have this came from a call to our customer care center out in San Jose, and they said, "Hey, you ruined my brake job." And we said, "Well, how in the world did we ruin your brake job?" I said, "Yeah, well, I had the vehicle in maintenance mode, and then I opened the door, and then my calipers just kind of blew apart because I didn't have pads in there, and they weren't mounted or anything. They were just kind of sitting there loose. I had to go in the door to get something." I said, "Well, that's a design flaw of the car. Not the best design, I don't think. I would think in maintenance mode at the very least, if the vehicle knows it's in maintenance mode, don't do that. I understand why they do that when you open the door. So it just applies the parking brake. The vehicle's parked, will just automatically apply the parking brake. Sure, cool, great. But if I'm doing maintenance on it and I have to put it in maintenance mode anyways, it should understand that it's in maintenance mode, in my opinion anyways. Of course, I'm not an engineer, so if you've watched this channel long enough, you know my opinion on automotive engineers. But anyways, also make sure you're thinking about it too and observing what's going on, because we've had calls in the customer care for this too. Hey, your tool doesn't have the function to retract the parking brakes on this car. And I believe it was a Murano, right? So some Muranos, depending on trim level, have an electronic parking brake. Others have a foot pedal. So they say, "Oh, well, I did brakes on a whatever age Murano 3 weeks ago, and it had the electronic parking brake. This one doesn't have it." Yeah, because it doesn't have one, right? So always be observant as well, right? We can all screw up sometimes. Just be aware that might be a thing. If you're looking for it in the tool and it's not there, just give it another look just to be sure that it even has that system on the vehicle, right? Makes sense. And in this case, this would be the inner drum brake system I was talking about earlier, right? With the uses traditional drum brakes, so it's just got a little actuator right there that actuates it, right? So, all right, let's go in the shop and we'll talk about doing brakes on a Pathfinder, I believe it is. So, let me turn off my camera. Okay, so as I said earlier, pretty much any vehicle with an electronic parking brake is going to need some sort of a functional test to open the calipers in order to replace the pads. Some vehicles, it just retracts the mechanism and then you simply press in the caliper like you would on a normal hydraulic brake system, or other times it will actually physically retract the caliper. So on this one, this is a Nissan behind me, that has the way where it actually retracts the caliper, and we'll be able to see what that piston looks like. So in order to do that though, we need to go into the functional test. So we'll go to ABS. It's going to communicate. Okay, and then we'll have to go into functional tests. And that would be a special function. Okay, and then we have down here we have start brake pad replacement or finish brake pad replacement. Now to do this, we're going to start brake pad replacement. So go to start. And it says, it is very important to follow these instructions, by the way, because every manufacturer is going to be a little bit different in how they do things. So make sure you're reading up on how to do it. So it must be performed prior to the replacement of the rear brake pads. Ignition must be on with the engine off. Ensure the parking brake is off before actuating the test. Now that is pretty much across the board. You got to make sure that parking brake is off, because otherwise it's going to be in that holding tight closed position. Sometimes the hood needs to be open, sometimes it needs to be closed. In this case, if it's equipped with a secure gateway, it needs to be unlocked as well. If we saw on the previous screen, the gateway is unlocked on this. Vehicle ignition must remain on until the rear brake pads have been replaced. So that's another key point on this one. If the ignition turns off, could cause an error. If the above conditions are met, select start to begin. So we'll hit start. It's going to bring us into the test screen. And it says press yes or continue to execute the function. So that'll be the right arrow on the top left of the screen there. I'm pretty sure you were able to hear that over the microphone. That was actually retracting. And you see the little dip where the battery voltage dipped as well. So now I'm going to set the tool down and we will pull this caliper off and take a look at what we can see. So... the thread lock on it. Go, nice and loose. We can pop it off. Now if we can see there, on the inside of that caliper, there's a gold piece, that's the piston, right? And it's got the two little tabs on the side. If you remember from back the older days on some of the manual e-brakes, or e-brakes back then, parking brakes, you would have to use a special tool to twist them in. So this actually twists in and out. So you would not want to compress this caliper piston back in order to do that. It's just this motor function. If you can kind of see on the back there, there's the motor assembly there. It's got the connector and then all the motors there. So I'm going to put this back on though. Let's just say, okay, we're all done. We replaced the brake pads. Now we need to put the caliper back on. Sometimes it's a little tough because of the hose, the way everything sits. And the way that motor sits kind of gets in the way sometimes. All right, and we'll just looser than I thought. All right. Same thing at the bottom. Okay. So let's say we've changed the brake pads at that point, right? We took the caliper off, put it back on. Anytime you do that, you should do this as well. Now it says test complete on the screen, which it said a while ago. If we back up, we can go to finish brake pad replacement because now we're done. So it says the function pushes out the rear caliper pistons after replacement of the brake pads. Attention, if the vehicle is equipped with a secure gateway, it needs to be unlocked. We already did that. After successful operation of this function, perform the initialization position adjustment if needed. And that's recommended to do if you have replaced the pads. In this case, we didn't, so we wouldn't necessarily need to do that. We're going to do it anyways, but that just allows it to adjust in case you do have thicker pads than you did before. So we'll just hit start. And it's going to bring us back into that test screen like we saw before. And then hit the right arrow to execute the function. You can hear it kind of go in, bottom out, and then retract a smidge. We can see the battery voltage drop as well. So once that's done, we can back out of the menu. And then we see halfway down there, initialization position adjustment. That's that adjustment after I would have replaced the pads. You want to do that. So it says ignition on, engine off, park brake off, transmission in park or neutral, position the steering wheel in straight ahead position, which we already have. Foot off the brake, vehicle parked on level ground. In this case, we still have it up in the air. But during the procedure, assure that no unnecessary vibration is applied to the vehicle, such as opening or closing the doors. If all conditions are met, select continue to perform this vehicle. So I'm going to wait till I get this back on the ground to do that. But we'd see if we go through here, it's going to give us the same type of procedure where we have to hit the arrow. You'd hit the arrow, it kind of closes at the same time, and then it would reinitialize everything. So I'll do that when I get it back on the ground. Another couple things that we can see up towards the top that are also inside the ABS modules, the steering angle sensor calibration. So if you do any work with the alignment, steering angle, we need to do that. Decel G sensor, side-to-side G sensor calibration. So all of those may need to be done depending on what the repairs are with the vehicle. Let's look at actuator tests, see what else we have. So ABS motor to actually test the motor. You can test the different solenoids, left, right, front, and rear. Parking brake indicator, so that'll just show you the light, brake operation, and brake release. So that's all to deal with the ABS module. So we also see we have codes, we have data in there. So we can see like wheel speeds and things of that nature. Let's just pop in there real quick and see what we got. So steering angle, battery voltage, wheel speeds, vehicle speeds, odometer, decel, side G sensor, yaw rate sensor, master cylinder pressure, tire diameter, electronic parking brake mode, actuator voltages, all the stuff that you might need, brake force, park brake switch, etc. So you can see all the different data that's available in there that you might need during a diagnosis. And then if we just back out, it'll go back to normal. It's going to double check it on security link, and everything's back to normal. All right, true to my word, vehicle's back on the ground, wheels put back on, torque to spec, go back in the ABS. And we'll go back into functional tests, special functions, and then we'll go to the initialization position adjustment. Ignition on, engine off, park brake off, transmission in park. Position steering wheel center straight ahead position, that should be at 0 degrees. Foot off the brake, vehicle parked on level ground. During this procedure, no unnecessary vibration applied to the vehicle, such as opening or closing doors. If all conditions are met, select continue. We'll continue in. And it says my steering angle is 0 degrees. That's where it needs to be to do this. So we'll hit yes or right. And there we go. It gives it a little squeeze in, squeeze out. Not sure if you could hear that on the microphone, but and then it says test complete. So forward to retry, back to exit, hit exit, and we're completely done with that brake job. All right, good stuff. Hopefully you got through learned a couple things there and learned a couple things through the class. So that is brakes. And with that, that's our time here today. So make sure you tune in for new diagnostic content every week. We'll be premiering a new video every Wednesday at 7 p.m. UK time, so make sure to check it out here on our YouTube channel. Please make sure you also subscribe, thumbs up, and ring that little notification bell so you'll know anytime we post new content. With that, time for questions. Now, if you have any questions, once again, if you're watching this on the premiere, just leave it in the live chat and we'll do our best to answer those. Otherwise, leave a comment under the video and we'll get to those as we monitor those comments as well. So I'd like to thank you for taking a little bit of time out of your day to learning a little bit more about how you might be able to be more efficient at diagnosing vehicles using some of the information that we've been giving you today. Hopefully we'll see you next week, and we'll see you on any of our other videos. Have a good week, have a good night, and take care.